Hi, I'm Phil, and we're going to continue exploring how to make simple robot arms with the Electfreaks kits. And in particular, we use the Initial Inventors Kit with microbit, and we needed a couple of extra servo motors to extend the degrees of freedom. So let's have a look at the projects that I've been working on. We're going to explore how we could go from 3 to 4 dimensions and how that has an impact on our design and performance. We'll also look at a project which is going the other way. So instead of 3, we're going down to 2 dimensions, and that's enough to create a smart telescope. And I'm going to do the inverse of that, a starArm, which points a laser beam to the star that we're interested in. And finally, we'll have a look at how we could use a smart lens using AI technology to identify objects that the smart arm or the robot arm can pick up. And we're really still exploring today. We haven't done our final project. And as a result of this exploration, we will be able to choose the hardware and the requirements for our final project. So let's have a look at the projects. We're going to have a look at this project, which is looking at extending. So we'll just go a bit further. This is what the project looks like. And that's our third project. So you can see that we've got on these photos 3 degrees of freedom. And what we're going to look at is extending that. See if we could have a look at the arm itself. This is what our arm looks like when we go to 4 degrees of freedom. So we've added another servo motor along that horizontal axis. And I need to weigh it all down using that extra weight. Okay, so we might move down and have a look at the design. We've got communications protocol, where we send from our remote servo the status of the stop. So when we send a command stop, it will stop the robot arm. And we're doing that for safety. We send the servo number and the angle number. And we should also add to that a fourth one, which will be the fourth angle. And we've got 2 presets. Safety-wise, we've got we're using LEDs as pilot lights, red and green, and mechanical. We're still going to use we're going to try and remove some of the components. We're getting too many components now on that central axis. And remote control, we're using our microbit. So for the hardware-wise, we're using the M5 catch, and the Planet X, we're using the Nisha breakout board, extra servos, and the LEDs for our pilot lights. And these Lego components make it very easy to actually construct the robot arm together with technique components like beams and pins. Software-wise, we won't go through all the code. Very similar. All we're doing is extending it so that we can see the extra servo and control that. And we might have a look at the other projects. So the next project we're looking at is an arm. So instead of going to 4 degrees of freedom, we're only going to go to 2 degrees of freedom here. Same joystick. But on the joystick, we're going to use the presets this time for our laser on and laser off. So the arm, so we'll just have a look at what the objectives are. With our 2 degrees of freedom, it's only going to be moving the vertical and the horizontal axis. I'm going to accept commands from the remote and the same safety that we had before, but in addition, we're going to have a laser switch, and we have to be careful not to point the laser at someone because that laser beam could harm their eyes. And we're going to use the microbit platform for both the remote and to control the servo motors. The presets, preset 1 will turn the laser on, and preset 2 will turn it off. I'm going to try and improve stability by reducing the length of that horizontal axis of the beam. And let's have a look at the design. Safety-wise, everything else is the same. We're going to use the microbit. And software-wise, we might have a look at that. Here's our code, and we might actually go across and have a look at that code now. So let's see if we can bring it up. Make code. And the one we're interested in is in the star laser. And here's the code for the star laser. So we'll go to the full extent, and we'll have only concentrate on those parts which are different. So let's go through that code. So you can see we're setting up radio group 1 for our remote control, and we're assigning number 1 for our servo motor. In the forever, we're checking the status of our stop, whether it's, and that we're sending those values of both the servo number and the stop status to our serial port to debug the program. Then we call check commands, process the presets, and check the warning lights, whether they need to be turned on. So if there are presets, we then process whether it's number 1 or number 2 to turn on the laser lights. And to turn on the laser lights, we'll just have a look at the commands for that. We've seen the ones previously for turning on the servo. So we've got extra buttons, a red button, and when we press the red button, it will turn the laser on, or the blue button will turn it off. And here's the warning lights. And finally, we've got the functions for turning the lasers on and off. And when we do that, we send a message to our serial port. Okay, so we'll have a look at that in a demo, a desktop demo shortly. Let's go back to our projects. In the final project, we're going to do a unit test of the AI lens. And what we've got here are 2 balls just under the camera, and on the end of our very simple servo arm or robot arm, it's only 2 degrees of freedom this time, we've got 2 end effectors. So on top, we've got the AI camera, and we want to be able to detect objects like these 2 balls. So this is what the setup looks like. So let's have a look at our objective. First of all, I'm going to do an exercise in updating the firmware for our AI lens. And I want to place the red or blue ball before the smart lens and get the system to recognize the color of the ball. So the ball can either be red, and if it is red, it's going to show red on a NeoPixel ring. So that's something that I've added in addition. If it's blue, it'll show blue on the NeoPixel ring. And it will also show the XY coordinates of the ball. And the idea here is we've got a very simple program, but it will be used, these concepts will be used so that I can get the robot arm to pick up the ball and deliver it to a target area. So you can see what the results are. We're going to verify that we've picked up the ball by putting on that extra laser lights. Okay, so this time we're using the microbit computer. We're using the breakout panel, and with this from Planet X, we've got new modules here. This time we're using the AI Smart Lens Kit and the rainbow LED module, which is a NeoPixel module. Software-wise, we might go and have a look at that in a minute. And the code is this one. It's quite simple. Let's go and have a look at the code. Just move across, and we're looking for our lens test. So let's move out. Not a lot of commands in the code. So let's go and have a quick walkthrough to see how it functions. So we're initializing the lens here, and we're switching the function of the AI to ball recognition. There are alternatives. We could have face recognition, card recognition, tracking, or color recognition. And we're setting up a NeoPixel strip with 8 LEDs, and that will go on port 4. And initially, we're just going to show green on that array. Forever, we just check the ball, the function for checking the ball. So if the ball is red, we turn the strip to a red, and we then map the coordinates of the ball to ball red or ball X for the X coordinate and Y for the Y coordinate. And we do something similar if it's blue. And that's all there is in the program. Quite straightforward. And if that works, we'll use it on our final program. And stay tuned, and we'll have a desktop demonstration. This is the 4th degree of freedom robot arm made out of Lego and driven by microbit computers. So we have one microbit computer as the remote control, and it's currently showing servo number 1. And we have a second microbit which is directly connected to the servos and a pilot light over here. And we're using the Electfreaks Nisha kit, the inventor's kit. So we'll have a look at the motors or the servos. So we have servo number one down here, and it's connected to servo 2. Then we've got servo 3 and servo 4. So we've got 4 servos, and that's actually putting quite a bit of strain on the bearings of those motors. So I previously wanted to mount a smart AI lens or smart camera, but it's independent. It's on the main frame, but I did want to mount it over here. So this is probably about the limit that you can go to. Let's have a look and see how it works. So at the moment we're disarmed, and to arm it we press button D. That means it's in a warning mode. The pilot light is red. And what we're going to do now is press the button on the, or press the joystick and just see what happens. So you can see there's a fair bit of swing and backlash. So the mechanical design is far from being perfect there. So we go and select joystick, servo number 2. So there's 2 selected, and 2 is on our controller, the microbit controller for the servos. So let's go and see how that performs. So you can see that it's moving around the horizontal axis. Then we'll go to joystick number 3, which is on the catch here. So we've got the catch. So we'll go to number 3 and we'll move that. That has to be moved in the vertical direction. There we go. So we've got number 3. And finally, we'll return that to 4. So we'll go to 4 and we'll see how that moves. It'll only be a small movement. And we'll just... So you can see that there's the 4th movement of our 4 degree of freedom robot arm. Here we have our robot arm version 3, and it's got 2 end effectors. On the bottom we've got a catch connected to a servo, and at the other end we've got a smart AI lens, which is a video camera with AI processing. And all of that's been handled with a microbit computer over here. And for this demonstration, we're only doing a unit test of the video. And what we want to do is see if the smart video can recognize not only that there's a coloured ball present, but it will give the coordinates of the ball. So let's go and have a look at it. So we'll have a quick look at the software first, and we'll move on. Okay, we've got the red ball under the camera lens, and the lights are showing a red colour. Now we might remove those and put a blue ball and see what happens then. So our lights go blue. And on the serial port, you'll notice that we've got the coordinates, the XY coordinates of the blue ball. So ball B for blue, and if we change that to a red ball, it will come up with the coordinates for the red ball. And that is the demonstration of smart AI video sensing. A demonstration of that. This is starArm. It's similar to a smart telescope, but instead of the telescope we have a laser pointing to the stars, and at the moment the laser's pointing to the ceiling. And the idea is that you give the coordinates of a star, and the smart arm, or the starArm, will point to that star with the laser. And it has 2 microbits, one for the remote control, and it's wirelessly connected to the local microbit over here. And it has a much simpler construction compared to the first video on robot arms. So we only have 2 servos, servo 1 with a direct connection to servo 2, and after that we have the mounting of our laser. So we might actually go and have a look at that now. So at the moment it's in the disarm position with the green light. That means you can enter the area. When we press button D, we arm the system. So it's now armed, and we're on servo 1 at the moment. Now if we go and press button A, we've selected servo 2, and servo 2 is this servo here. So it's going to move in the horizontal axis, and we can move it with our joystick. So we might move that now. Here, there we've got our servo, and the actual laser light is on at the moment. Now to turn the laser light on and off, we use the presets. So we're going to use preset D, and that will turn the laser light off. I'm going to turn it back on again. So we've got C and D control the laser. So we've got our laser back on again, and the laser is pointing to the ceiling. So there's our laser spot there, and it's coming from the laser on the arm. And we can also control the vertical axis. So if we go back to servo 1 and use the joystick, we'll just move it now. So you can see there's the control of the other one. And we have an emergency stop for our laser. So if we want to turn the laser off manually, we just press the red button here, and it goes off. So we've got a red button. And if we want to turn on the laser manually, we can just turn it on here. And that's our StarArm using 2 microbit computers with components from the Nisha microbit inventors kit, with an extra servo motor, Lego bits, and a push button, and 2 pilot lights.